So at 5.5, we have a couple of things. We have some special types of linear systems, and it has a little bit of review in here as well. The special types are going to be things that we know. We know that lines can either intersect, and that's one solution. They can be parallel, which is no solution. Or they can be the same line, which is infinitely many solutions. So with that being said, I also know that a no solution, when I solve it, a regular equation, it would be like a false statement. And if we know it's going to be infinitely many, it's actually going to be a true statement with no variables. Remember that, no variables and it's a false, or no variables and it's true. Otherwise, it's going to be like an x equal or a y equals. You're actually going to get a number. Remember, 0 is a number. All right, so when we go to solve the system, think about the different ways that we know: graphing, substitution, and elimination. I'm going to encourage you not necessarily to graph them all the time, but to actually use substitution or elimination, because those are actually solving like number-wise. You're actually crunching numbers and getting exact values. So this first one, I would say it's set up for substitution, because I have a y equals this quantity and I can plug it in. So I'm going to plug it in for this y. So I would tell you that x plus 2 times the 3x plus 2 put in that quantity equals 11. And we're going to solve for x, because it's the only variable I have. So x plus 6x plus 4 equals 11. So 7x plus 4 equals 11. Take away 4 on both sides. I get 7x equals 7. So x is equal to 1. So x equals 1, I'm going to plug that back in, and I'm going to plug it right back into my initial statement. So y is equal to 3 times 1 plus 2. Y equals 3 plus 2, so y equals 5. So my solution would be 1, 5. These are intersecting with one solution. The next one. This is set up in, they're both in standard form, so ax plus by equals c, they're all lined up. I do have to do some manipulation, so I'm going to have to do some manipulate and then eliminate. I'm going to multiply this top one to get rid of my x's by a -2. So when I do that, I end up with, I'm going to put it down below, it's going to give me -12x minus 2y equals 4. Now I'm going to work with these two equations. And when I do that, I end up with those go away, those go away. So 0 equals -2. Well, I have no variables, and this is false. So this means no solution, because they are parallel lines. The next one is set up, I've got a y equals, so it's actually set up for substitution. I'm going to plug that in. So -21x plus 3 times 7x plus 13 equals 39. Distributive property here, I end up with -21x plus 21x plus 39 equals 39. These guys cancel, so I'm left with 39 equals 39. No variables. This is true, so it's a true statement. No variables, so therefore it's true, which means infinitely many solutions, because they are the same line. If I rearrange these, they would have the same slope and the same y-intercept. The next one is standard form. They're already set up that way, nice and tidy. So I can actually just combine them, and I get 8x, these cancel, equals 0. Divide by 8, x equals 0. Now this is x equals 0, okay? I still have a variable, so it's an actual number. That is a value. So x is 0. I'm going to say 4 times 0 plus 3y equals 27. That cancels, so 3y equals 27, and divide by 3. So y equals 9. Now I have an x value and a y value. So these are intersecting. And so I have one solution. And my one solution is 0, 9. 0 is a number. The bottom one here, I'm looking at it. It's set up kind of for standard form, but we do have to do some manipulating here. So I'm going to probably get rid of my y's. I'm going to multiply this top one by -2 and the bottom one by a +3. I'm going to write my new equations out here to the side. So I'm going to end up with -8x plus 6y equals -16, and 15x minus 6y equals -33. Y's cancel. This gives me -8x plus 15x. This gives me 7x equals 9, be 49 negative. Divide by 7, so x is equal to -7. And I can pick one to plug it into. I'm going to pick the top one. So 4 times -7 minus 3y equals 8. -28 minus 3y equals 8. Add 28 to both sides, so I end up with -3y equals 36. Divide by -3 on each side. Y is equal to -12. That's one solution, so I'm going to end up with -7, -12. One solution, meaning they're intersecting lines. And then go to the next page and try these on. All right, so F. So on F, these are set up for elimination. G is going to be eliminate, but you're going to have to do a little bit of work multiplying the top one, I would say, by like a -3. H, you're going to have to subtract, so I'd multiply the bottom one by -1. And I, they're set up for elimination as well, but I'm going to multiply the top one by 2, so things will cancel. And that's it. So here we go. These, when I cancel them out, these cancel and these cancel, so I get 0 equals 14. That should be like a quick answer right away. What is that? It's like true or false. Okay, it's false. No solution because they are parallel. Next one, multiply this out. I'm going to get -6x minus 15y equals -12, carry the 1, be 3, be 42. Now use these bottom two. These cancel. I end up with -8y equals -32. Divide by -8, y equals 4. So it's going to have one solution. Plug it back in. 2x plus 5 times 4 equals 14. 2x plus 20 equals 14. Take away 20 on both sides. 2x equals -6, so x equals -3. And so I get -3, 4. Again, you can pause me at any time. One solution intersecting. The next one I'm going to multiply by -1, so it gives me -1, x plus y equals -1. Now canceling, they cancel, I get 0 equals 5. Again, this is false. So no solution because they are parallel. And the last one, if I multiply everything by 2, I'm going to put it down below here. I get 6x minus 6y equals -4. Put those two together, I end up with 0 equaling 0. Okay, 0 equals 0. That is a true statement. So that means all real numbers are infinitely many solutions because they are the same line.